Okay, let's begin with number 5. The height of a punted football can be modeled with a quadratic function. H is equal to negative 0.02x squared plus 1.15x plus 2.3. The horizontal distance in feet from the point of impact, which the kicker's foot is x. Okay? And h is the height of the ball. So they're telling us that h, that's the height of the ball. And the x represents the horizontal distance. Let's put that over here. Horizontal distance. Horizontal, which axis is horizontal? Right, the x-axis. So you know when you're looking at your table, your x is your horizontal and your height is your vertical or your y. So if you were looking at a table, your x would be your L1 and your height would be your L2. Or that's if you put your values in. If you're not going to put your values in, then you can just look at your table when you put your equation in y equals, and you can go from there. So let's check this. Let's go ahead and do this. Okay, for A, what is the ball's height when it has traveled 10 feet down the field? So we're going across the field. Down the field is horizontal. So would 10 feet be your x, or would it be your h? Horizontal distance is x. So we can actually put this equation in the calculator. So that's what I'm writing down just to give you a little memory, something you can use to remember. And then we can look at the table. So we want to know when x, which is our horizontal distance, when x is equal to 10, what is y, which is our height, which is h. So you can do it two ways. You can plug in 10, or you can do it like that. So when x is 10, I'm going to go down 10. I can put that in my calculator. And when I look at my calculator, when x is 10, I see 11.8. So when x is 10, the height is 11.8 feet. Which means, since this is distance, at a horizontal distance of 10 feet, the height of the football is 11.8 feet. So this is the answer we're looking for A. Now let's go for B. What is the maximum height? For maximum height, what are they really asking you for? Right. They're asking you for the vertex, but what part of the vertex? Right. They're asking for the y coordinate of your vertex. So because y is represented, the h is your y coordinate. So we're looking for the y coordinate of our vertex. So first we have to find our vertex. Since this is in vertex form, we can find the vertex by using, first we find x is equal to the opposite of b over 2a, which is our axis of symmetry, and also our x coordinate of our vertex. So what is A? Negative 0.02. Good. What's B? 1.15. Right. And what is C? So C would have to be 2.3. Good. So let's plug. The opposite of 1.15 divided by 2 times negative 0.02. And then we work that out. I've already worked mine out. So let me see what I have. Okay, I got 28.75. So you can check that. So our x coordinate is 28.75. How can we use that to find our y? Right, you go back to your original and you plug in So h is equal to negative 0.02 times x squared. X is 28. I might put that in a different color. That's going to be 28.75 squared plus 1.15 times 28.75 plus 2.3. So I took this equation, and now I'm going to plug in what we got for x into x for our quadratic equation. All right, and go ahead and do that. Figure that all out. Use your calculator if you'd like for that. That will save you time. 13 feet. And then if we go over here, the answer for C is 28.75 feet. So the distance downfield is 28.75 feet. So that's actually the x coordinate of your vertex. Okay, so that's letter C. And letter D, the nearest defensive player is 5 feet horizontally. Think about what you think about that. From the kicker's foot. How high must his hand be to block the punt? And then we want to, so what they're asking you, let's see, we are on letter D. They're saying that the horizontal distance is 5 feet. They want to know the height at that point, that the hand of that player the hand of the defensive player has to be to block the punt. And so that's our unknown. How can we find that answer? You can do it two ways, right? You can look at your table, and when x is 5, what is the height, or what is y? Or you can plug 5 into your original equation, and that will also give you an opportunity to find y. So what you find out is, for letter D, you're going to get 7.55 feet. That's how high the blocker's hand has to be to block the point. The punt, sorry. And let's go to letter E. I'm going to erase these. E says, suppose the punt was not blocked, but continued on its path. How far downfield would the ball go before it hit the ground? How high is something when it hits the ground? How many feet up is it from the ground if it's hitting the ground? Good, 0. So we want to know how far the ball goes before it gets to 0. You can look at the table and get an approximation by seeing where your y becomes 0. If you can't really see where it's 0, sometimes you can tell where it goes from a positive to a negative, and that gives you a clue that it's between those two numbers. So if you want the exact value, then I'm going to show you how to get that. Let's see. There's your A. Okay, so we're on E. So what we have to do is we want to know what is X. What is X when the height is 0. That's what we want to know. So you take and you make your height 0. And then you say, can I use the X factor? Can I use my X box? Where you multiply first times last and then put your magic number. If you use that, you won't be able to factor this. So we're going to use the quadratic formula. X is equal opposite b plus or minus square root b squared minus 4ac divided by 2a. So x is equal to the opposite of b plus or minus square root b squared minus 4 times a, negative 0.02, times c, divided by 2a. So now you're just plugging in. Okay, and so after you've plugged in, you want to compute and find out what you're going to get. After you do your calculations, you're going to end up to So x is equal to negative 1.15 plus 1.227 divided by negative 0.04, and x is equal to negative 1.15 minus 1.227 divided by negative 0.04. And at this point, this is where I got x is equal to 0.077 divided by negative 0.04. And then I got x is equal to negative 1.925. Can you have a negative height when you're talking about the ground? Nope, you'd be underground, so let's not do that. So now let's look over here to where we had to subtract, because you have your plus and you have your minus. So x is equal to, and right over here that's negative 2.377 divided by negative 0.04, and we get x is equal to 59.425 feet. Let me make sure you can see all of that. Okay, so the question is, what is x when h is 0? Or if you actually look at the question in real world terms, suppose the punt wasn't blocked, how far down the field would the ball be when it hits the ground? The ball will be about 59 feet down the field when it hits the ground. Alright, so now let's move on to letter F. The answer to this one is 59.425 feet. Y is the linear equation. H is equal to 1.15x plus 2. Why is that not a good model for the path of the football? They just said it's a linear model. So if you throw a football, is it going to go up in a straight line to infinity? Or is it going to go up and come back down? Right. If you throw a football, your football is not going to just go up, 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 up to the sky. No, it's going to go up and come back down. So a linear model would not be a good model for you throwing a football. But this parabola or quadratic is a good model. So you can write your reason from there. This equation of the straight line does not take into effect that the football is going to go up and then come back down. Write that in your words.